This video will serve as a review for some and an introduction to others. Either way, we're going to cover prime numbers. And so our formal definition of prime numbers is a whole number greater than 1 that cannot be exactly divided by any whole number other than itself and 1. So basically, division can't result in a fraction or a decimal. And our examples I have is 2, 3, 5, 7. I want to show that 2, for example, is a prime number because, like our definition says, we can only divide 2 by either 2 or 1 and still get a whole number. Any other number, if you divide 2 by that number, it will result in either a fraction or a decimal, but it will not result in a whole number. So if I divide 2 by, 3, that's not a whole number. If I divide it by 4, it's not a whole number. 5, not a whole number. On and on and on. You could not tell me a single other number other than 2 and 1 that 2 can be divided by and still get a whole number. So that's what makes 2 prime. Now, some important terminology. We want to know what factors and products are. Product is a math word they use when you say you multiply two things together. So if you say multiply 3 and 2, the product of 3 and 2 is 6. And if you had these two binomial terms, multiplying them together would give you the product. So the product of x plus 3 times x minus 1 is this. And 3 times 2, well, that would mean that 6 is the product of that. Or what is the product of 3 times 2? It's 6. And reversibly, if you have a product, you can split it up into what two numbers you multiplied to get there. So taking the product of 6, it has factors of 3 and 2. So factors are the building blocks of multiplication that get you to a product. And same here, which we're going to learn about soon enough. This is a product. However, these were its factors. So even though this looks like kind of a mess, you can split this up into two different things that were multiplied together to get this sequence of terms. And so with those out of the way, we're going to talk about prime factorization, which is one of the key concepts of this video. Prime factorization means that you're taking a number, any number, and you're factoring it until you have only prime numbers all multiplied together in a row. And so that's going to be a very important concept later on in some of our sections. So we're going to start with 8 in this example. And the way I like to do this is I like to first break it down in sort of a tree branching, like root-like pattern. And so I'm going to take, and it doesn't matter what two factors you start with, it could be just the first two that come to your head, because no matter what, you will end up with the same prime factors. But I'm going to take two factors that aren't the number in 1, so 4 and 2 are our only options here. And I'm just going to factor it. And then I look at these two, and I say, well, 4 times 2 is 8, so we did that correctly. Are either of these prime? And I'll look at that and I'll say 2 is prime, so I'll stop right here. But 4 is not prime, so I'm going to factor 4 now. Now I stop right here. I say, are either of these prime? They're both 2, so they're both prime. So I say, okay, I'm done now. So I take every end of my branch, and I say that 8 has a prime factorization of 2 times 2 times 2. And that's how I usually represent it. But now we're done. This is how you would do a prime factorization of 8. And we can do another number. Let's do, 48. Why not? So the first two things come to my mind are just splitting it in half. So 24 and 2. 2 is prime, so we stop this branch here. 24, however, is not prime. So we can keep this going. And let's say it is 3 and 8. Now, 3 is prime, so again, we stop this branch. 8, however, is not, and we just did 8, so we can know that this splits into 4 and 2. 2 is prime, and then 4 splits into 2 and 2, and 2 is our prime. So now, we have this long branch, and we can use this to say 48 is the multiplication, or the product, of all of the ends of the branches. So we have a 2 right here, we have a 3 right here, 2 right here, and then 2 more 2s. And so 48, the prime factorization of 48 is going to be 2 times 3 times 2 times 2 times 2. And you can organize that a little bit neater, but that's the prime factorization. And so you can also do these with variables. However, it doesn't really work in that sense. But to factor a variable, I just want to point out that x cubed per se would just be x times x times x. And this wouldn't necessarily count as prime factorization. It's just factoring. So I should, maybe should have clarified that. But in general, prime factorization, you can list them out in a branch, as I did, and I find that the most helpful. And then when you're done, you collect all of your ends of your branches and list them out in terms of multiplication. And so that's how you complete the prime factorization of a number. And if you ever end up with something that's not a prime number, then you know that you either have more steps or you've messed up somewhere. But that is prime factorization. If you have any questions, leave them in the comments. And if you thought this was helpful, like and subscribe.